Alright, so today's video is about measuring techniques, so things you need to keep in mind when you're making measurements. Now, a few things in here you guys might know already, and that's okay. We are just recapping some of these because this is based on things we've seen. There are going to be a few things in here you're going to go, well, duh. Well, we've seen people that didn't necessarily know all these things. So make sure you pay close attention because measuring is a very key part of this class, and to make sure you measure, very precisely is a very important thing, and accurately.
Yeah.
All right?
Yep. If you can't make good measurements, you can't get good numbers, you're not going to do well on these things. It won't make sense to you. Going off of that, the first thing we have, let's talk about distance measuring tips. These are pretty basic. You guys probably know these, but just in case. Always use the metric side. We're not using English in here, so no inches, no feet. It's going to be meters, millimeters, centimeters, something like that. And along those lines, make sure you guys are always reading to the nearest millimeter, so that'd be the nearest thousandth on there. And again, I've mentioned our unit is meters on this. Make sure when you're using that you start measuring from the zero line on your ruler. You can see in the picture right there that the object, the striped object that they're measuring there, is lined up with the zero on the meter stick. And if you look at that, it looks like it's about 7.7 centimeters or 77 millimeters.
Yeah.
And if you remember our video from before on conversion, some of that will hopefully make sense to you.
Yeah, remember, don't go just to the nearest centimeter, go to the millimeter, because if we did it wrong, we'd say 7
Yeah,
or
we'd
8,
say
right?
7 or 8. We're not rounding on this thing. You could say 7.7 centimeters, 77 millimeters, but other than that,
For massing, there's two main ways that you're going to get the mass of something. The first one is using something called a triple beam balance. Triple beam balance have 3 beams, just like it says. So there's 3 different sliders you're going to work with. You always want to start with the biggest one, so the hundreds beam. Once you move that, if you need to, just put it back to 0, or you just keep adding to it. But start with the hundreds, then you're going to move to the tens, then you're going to move to the ones finally. And eventually you're going to add all 3 of those numbers together and estimate the decimal place. The decimal place will come from the 1 slider. But that's for measuring in grams, and that's the triple beam balance. So 3 beams, start with 100, then do the tens, then do the ones, add them together, include a decimal.
and we're going to show you a video of that right now.
All right, welcome. Here we are. We're going to show you how to use a triple beam balance today, and my friend Godzilla is going to help out. And one of the things you want to do before you put anything on, notice that the 2 lines here should match up. So the 0 over here and the line there need to match before you start. Put Godzilla on top there. Hopefully he doesn't fall off. You're going to start by moving the big bar, which is the 100-gram one. And there's these little notches that you want to set it into. And if you notice, when I was at 100, it's up there. And when I hit 200, it drops it down. That tells me that I know it's less than 200 grams. Now I'm going to move the little tens bar up one by one until it falls down as well. And if I hit the 30, it drops below, so it tells me it's less than 130 grams. So I'll go back to my 120. Now I'm going to use my little 1 gram bar here and just kind of slide this along, watching for this and trying to get it so that the lines match up. Once the lines match up, you probably have your measurement. And I'm almost there. And right there looks pretty good, almost at about 121.9 grams. And there you go.
All right, welcome back.
Magic.
So the next thing we're going to use to find masses is the electronic scale. Now this is a little simpler than the triple beam balance because it pretty much just spits out a reading for you. But a few things to keep in mind. You want to make sure that nothing is actually on the scale when you turn it on. I'll show you why in a second. If you put something on there that you don't want calculated into the final mass, like let's even say there's some water sitting on there because you've been measuring something that's wet. Hit the 0 button on there and it will kind of zero out everything that is on the scale. Okay? And this actually does tie in really well with number 1. It's just separate situations. And this will become clear in a second. And finally, just one thing, people get impatient with these electronic scales. They do take a bit to get a final reading on it. So be patient. And don't get too close to the scales because I have seen people breathing on the scales actually makes your measurement vary a little bit.
Yeah, they're very sensitive.
So kind of step back and just be patient. It doesn't come up with an automatic reading. It takes a few seconds, but then you'll be good.
And you'll see that in a video right now.
All right, so one thing to keep in mind when using an electronic scale, let's say you leave something on the scale and then you turn it on. So I left this binder clip on. Now, as I said, whatever is on the scale ahead of time, the scale is going to recognize as being 0. Okay, so you notice the reading says 0 even though there's clearly something on there. Now let me take this off and you notice it says it's negative 8.3 grams. Okay, now we know that's not the case. Now here's the good news. If you ever have some weird reading that you need to get rid of and you say, okay, let's zero that out, hit that on, zero off button, and it goes to 0.0. So let's take the mass now of our nice bathroom pass. All you do is just put it right on the scale, let it sit for a second, and you'll see it eventually levels out to 95.9 grams.
Okay, guys, and welcome back. The next one we're going to talk about is tips for measuring the volumes of liquids. Graduated cylinder. That's our buddy. Remember we talked about all the little graduations, made that the most precise piece of equipment that we have there. It will give you the most accurate measurements. Keep in mind, you guys, never measure liquids directly out of like a bottle or chemical container, any of those kind of things, or out of the faucet. I've seen kids go back and forth a million times the graduated cylinder trying to get the drops exactly in there. Just use a beaker. Get an approximate volume you need in the beaker and then carefully pour it into there. Maybe use a pipette to add or remove a volume to get yourself a nice, accurate measurement with your graduated cylinder.
It'll be more efficient.
It will
and
be
it's
much.
more safe,
You're
too.
not going to save time by trying to get it out of a big bottle or out of a faucet. It just won't work. Remember, guys, it's volume, so we're talking liters.
The other thing when you're measuring with a liquid with a graduated cylinder is you want to use something known as the meniscus. Think of it like the meniscus is like an upside down bubble. So a bubble of water goes like this, the meniscus actually kind of goes like this. You want to measure at the bottom of that little bubble, and that's going to give you the most accurate measurement you can using that. You can see the picture down there, and we'll show you in a demo.
All right, and then also keep in mind that we do, although we said the base unit is liters, we usually do measure in milliliters.
It's a smaller volume, so you're usually going to talk about milliliters.
All right, so now let's say you're trying to find the volume of just a regular old solid that is box-shaped. Okay, now there's a very basic formula for this. Maybe you guys have come across this in your math classes before, but all it is you take the height times the length times the width.
Yep.
Those three dimensions, that's all you have, and you have what's called cubic centimeters. Now, a cubic centimeter is whenever you take the volume of any solid.
Yeah.
And a milliliter is what you take in a liquid. Now, the thing is, they're actually the same thing.
And we'll talk about that in class.
But if you've ever seen a show like with medical stuff, like ER or something,
CCs.
they say 10 cc's is something. It's something that's liquid.
Yep.
They're actually referring to cubic centimeter, but it's the same thing as a milliliter.
Yep.
They're actually the same thing. Okay, but for special cases, when you have an irregularly shaped object,
Like a human.
you will use something called the water displacement method.
This is mine. I'm doing this one. If you guys got an odd-shaped solid, what you want to do is, just like you said, a thing we call the water displacement. And what you need to do is you put a known amount of water inside your graduated cylinder. It doesn't matter what the amount is, you just want to know what it is ahead of time, because this is a kind of before and after comparison. So what you do is, as you can see here, like say we put 10 mLs of water into your graduated cylinder, then you take that little rock that you drop in there, or any odd-shaped little doodad or action figure, and you put it in there as long as it fits in the graduated cylinder. And then you see how far that water level went up by reading the bottom of the meniscus. The difference between where it started and where it ends up at is the volume of that object you dropped in there. So you have to do some subtraction. So you take the bigger number, you'll take out that initial volume, and you'll be left with just what the volume is of that last object. And we're going to show you a video on that right now. Okay, guys, let me show you the water displacement method for finding the volume of an odd-shaped or maybe, like you could hear, a regularly shaped solid. In this case, we have this little bitty magnet. I've got my graduated cylinder with a known quantity of water inside there. And if you take a look, you can see here's 20 mLs. We're not at 30, so if you count up, we go to 25, 26, and read the bottom of the meniscus. Our starting volume, the volume of water alone, is 26 mLs. Now what we need to do is we need to carefully load in our object so that we don't break the bottom of this or splash water all over the place. You don't want to splash water out either. Drops down to the bottom, goes like a rocket. And now you can see the volume went up. How much it went up is the important thing. If we take a look now, it's at 25, 6, 7, 8, maybe about 29.5 mLs. So if you look here, then we're going to record our new volume, 29.5 milliliters, which is the volume of the water plus the magnet. So what we have to do is subtract the initial volume of the water, which is 26 mLs, away from our total of the water in the magnet, 29.5. And what that gives us is 3.5 milliliters. But remember, guys, this is the volume of a solid. We turn that milliliters into cm cubed, cubic centimeters. So what we get then would be 3.5 cm cubed, because remember, 1 ml is 1 cm cubed. You use it when you're talking about solids.
Wow, that was pretty cool.
That's
Yeah.
amazing.
Good
Wow,
job, guys.
I love that one.
All right, so that is it for today.
And you're going to do this a lot in class, so you get tons of practice.
All right, see you later.